Hello guys, this is Wit Lounge, Learning Made Easy. And in today's video, we are going to be considering an important concept known as order of reaction. Now, before we get into the study, please remember to like, share, and subscribe. Thank you. Now, for you to understand the order of a reaction, I would like to first establish a particular law which is known as the rate law. And what does the rate law simply state? It simply states that the rate of a particular reaction is directly proportional to the concentration of the reactants. So if, for instance, I had an equation A plus B reacting to give me C, the rate law simply states that the rate at which this reaction would go is directly proportional to the concentration of A multiplied by the concentration of B. Now, these concentrations usually possess particular powers, and these powers is what defines the order. Now, let's consider an appropriate definition for the order of reaction. The order of a reaction can be defined as the power dependence of the rate on the concentration of all reactants. That is to say, once you consider the power of the concentration in a rate law expression, that power is what defines the order of a reaction. Now, that is a mathematical explanation of it. What does this definition actually imply? It simply implies that the order of a reaction will tell us the number of species whose concentration affects the rate of reaction. What do I mean by that? If you have a reaction and you notice that they tell you that this is a first order reaction, it simply means that only one substance or one species affects this rate. That is to say, the rate of reaction only changes when the concentration of one species changes. If you say it is a second order reaction, it simply implies that the rate will change if only the concentration of two species changes. If it is a third order reaction, it simply means that the rate of the reaction will change if and only if the concentration of three species changes. So the order of reaction simply shows us how many species will affect the rate of reaction. Now, before we get into mathematical expressions of the order of reaction, it's important to note the following. First of all is that order of reaction does not depend on the stoichiometric coefficients corresponding to each species in the balanced equation. What does that mean? Let's go back to our board to see what we mean by that. So what it actually means is this. If, for instance, you have a particular reaction, 2NO2 reacting to give NO plus O2. Let's say, for instance, yes, we have 2 here, and this is a balanced equation. Now, if we are looking at the active masses of this substance, the active masses of NO2 would be NO2 raised to power 2. What that statement simply means that the order of the reaction is not dependent on this power that is gotten from the balanced equation. It can vary at any point and will be determined by an experiment or trials. And we'll get to the mathematical expression to help us break down and understand those things. But just have that in mind. Now, the order of reaction is not necessarily expressed as the power of the active mass. Have that in mind. When you are dealing with the active mass, when you are talking about equilibrium constant. And equilibrium constant, we deal with the law of mass action, which relates the rate to the active mass. However, when dealing with rate law or order of reaction, you are not necessarily dealing with the number of moles in the balanced equation. That's just the simple explanation of this particular concept. So let's get to it. Now, having said that, the second point to note about the order of a reaction is that the reaction order of a chemical process is always defined with the help of reactant concentration and not with that of the product. So anytime you are asked to find the order of a reaction, one thing must come to mind, and what is that? You are only considering the concentration of the reactants. One of the reasons I'm mentioning this is because when you go to things like equilibrium constant, where you deal with the law of mass action, you will notice that equilibrium constant deals with a reversible process in which the concentrations of the reactants and products are involved. But in determining order of reaction, you are only considering the concentration of the reactant. Okay, so I believe you should have a little understanding of chemical equilibrium and kinetics to be able to flow with this. Now, the next thing we are going to get into, having explained that, is a mathematical expression which describes the order of a reaction. So take for instance, you are given a particular um, expression. How do you find the order of the reaction with that expression? It is obtained by adding all the exponents of the concentration in terms of the rate expression. So let's go to the board to see what we mean by that. Now, once you are given a particular rate expression, take for instance, they tell you that the rate law is expressed as R equals K bracket A raised to power M multiplied by B raised to power N. As I said, the order is simply the power dependence, which is the power found on this reactant. So if I want to know the order of this particular reaction, it is going to be expressed as order of reaction will now simply be given as M plus N. So if, for instance, I have a rate law expression, and the rate law expression is given by K, and I have something like NO2 times, let's say I have like, okay, let me give another example. So imagine, for instance, I have nitrogen and hydrogen reacting. That is to say, the concentration of nitrogen multiplied by the concentration of hydrogen. Let's say here I have 1 and here I have maybe like 4. If I want to know the order of the reaction, I'll simply add these powers in this concentration, and the order of the reaction will now be given as what? 1 plus 4, which is 5. What does this mean? It means that there are 5 species that are considered, or 5 species that can affect the rate of this particular reaction. So that's that basically. That the mathematical expression to describe order is simply the sum of the powers on the concentration of a rate law expression. So once you show a rate law expression, check the concentrations and add the powers of those concentrations, and automatically you will get the order of the reaction. I'm just giving us simple tricks or easy ways to solve this thing. Now, we are going to be going through certain experiments, and as we go through the experiments, we would consider the different orders of reaction, basically. Let's start with the first order of reaction to be considered. The first order of reaction to be considered is what we refer to as the zero order reaction. The zero order reaction is simply, okay, let's define it. The zero order reaction is a chemical reaction wherein the rate does not vary with the increase or decrease in the concentration of the reactant. What this simply means is that a zero order reaction is a reaction whose change in concentration does not bring about a change in the rate. So once you change the concentration of a substance and it does not bring about a change in the rate, automatically we are referring to that as a zero order reaction. Let's get to the board to understand this. Okay. So imagine, for instance, I have reactants. Let me use concentration of A as a reactant, and this is the rate for A. So let's get to work. Imagine, for instance, I have 0.01, and the rate as calculated was given as 1. And then I change the concentration or increased it by 2, and it becomes 0.02, and the rate still remained 1. Notice something, that the change in concentration did not affect the rate in any way. So automatically, this is a zero order reaction. Even if I increase this thing by 100, and then multiply this by 100, and this becomes 2, it will still remain 1. The implication of this statement is that the change in the concentration did not affect the rate in any way, and that is what we refer to as a zero order reaction. So once you look at an experiment and you notice that the concentration is changing but the rate is constant, what happens here is that this is referred to as a zero order reaction. Moving ahead to the next one, which is the first order reaction. Now, a first order reaction is simply described as a reaction in which the increase or the factor of increase in the concentration is the same thing as the factor of increase in the rate. See what I mean? If you have 0.01 and initially it was 1, and then it changed and became 0.02, you increase the concentration by a factor. How do you get that factor of increase? It's simple. Let's see. How to get the factor is you divide the final by the initial. So factor of increase is equals final value all over initial. So factor. So let's get the factor for here. It's going to be 0.02 divided by 0.01. Once you do that, it's going to be 2. So the factor of increase here is 2. So imagine the rate increase from 1 to 2. How do we get the factor of increase on this side? It's going to be 2 over 1, and it's 2. Now, as I said, a first order reaction is simply a reaction in which the factor of increase of the concentration is exactly the same thing as the factor of increase of the rate. That's what we refer to as a first order reaction. So, in other words, we can also say that a first order reaction, if the concentration of a substance is increased by a factor and the rate increases by the same factor, it is said to be a first order reaction. Okay, so let's get to the next one, which is the second order reaction. Now, if the concentration of a substance is increased by a factor and the rate increases by that same factor raised to the power of 2, it is a second order reaction. Okay, so which means we are considering the powers now. Now let's get to understand this by a mathematical expression. Imagine, for instance, we have a reaction, and this is the trial. The experiment has been done, and this is the result of the experiment. You will notice that the concentration increased by 2 in this case. Okay, let me use a different color for the factors. So the concentration increased by 2 in this case, but here the concentration increased by 4. So notice that this is definitely not a first order reaction. Now, how do we determine what order of reaction? Bring these two values to the same base, that is to base 2. And how do we bring it to base 2? Ask yourself, how many times will I multiply this particular factor for it to give me 4? And you'll notice that this is going to be equals 2 times 2, which is 2 raised to power 2. So once you've brought it to this level, automatically you will notice that the order of reaction is 2. And this is going to be referred to as the second order reaction. Why? When you increased the concentration by a particular factor, the rate was increased by that factor raised to the power of 2. So once it is increased by the same factor raised to the power of 2, it is referred to as a second order reaction. Let's consider another example. Let's find the factor of increase here. I told you how to find the factor is this divided by this. So this is going to be 0.03 divided by 0.01. And the factor of increase here is going to be 3. Now, for the factor of increase in the rate, it is going to give us 9. What you need to know, this is not a first order reaction because it's not 3 and 3. So let's find what order of reaction is. Bring these two things for them to have the same base. So how many times will I times 3 to give me 9? And you notice that that's going to be 3 times 3, and that's 3 raised to power 2. This particular power is what represents the order, and this particular power indicates that this is going to be a second order reaction, basically. Okay, so if we consider a third order reaction, basically, we would now define a third order reaction, or maybe we'll describe it this way. If the concentration of the substance is increased by a factor and the rate increased by that same factor raised to the power of 3, it is now referred to as a third order reaction. So this is like a basic trick that once you look at a table showing the relationship between concentration and rate, you just find the order of reaction. So let's get to it. So let's consider this. The factor of increase here is 2. How did you get the factor of increase? You simply did this final divided by the initial, which is 0.02 divided by 0.01. So this is 2. Then find the factor of increase here is 8 over 1, which is 8. Now, the factor of increase is not the issue. The point is, how many times did you multiply these 2 to get this 8? That is what is going to give you your order of reaction. So what do? We'll do 2 times 2 times 2, and that is going to be 2 raised to power 3, which means the order of this reaction is 3, basically. So have that in mind, that if a particular concentration increases by a factor and the rate increases by that factor raised to the power of 3, it means that this is a third order reaction. So which means that the power of the increase in factor is what we are considering when we are using this trick to find the order of reaction. Okay, let's now consider an appropriate experiment, having understood how to determine these things, where we now have 2 reactants involved. Now, in these experiments where you have 2 reactants involved, what you basically need to understand is you would check the concentration in relation to the rate for one of them before you go to the other. So we have two reactants, A and B. So we're going to check the relationship between the concentration of A with respect to the rate, and then check that of B with respect to the rate. Now, please note, when you're taking that of B, the concentration of A should be constant. And when you're taking that of A, the concentration of B should be constant. That should be the same thing. So if you notice, between our first and second trial, you notice that the concentration of A is the same thing. So, which means we are going to be considering B independently. Now, let's write out our values basically, because it's going to help us understand this better. Now, so putting down my values, I have the concentration. I'll just put it down here. Concentration of A, and I have the concentration of B, and then I have my rate here. So let's get to work. The concentration of A initially in the first trial is 0.1. The concentration of 100. The concentration of B is 0.100, and the rate is 1.0 times 10 raised to power minus 6. Now, in this experiment, A was made constant. So let's make A constant. And once A is made constant, it means that you are considering the concentration of B. That's, you're finding the order, you're looking for the order of B with respect to the rate. So let's do that. You notice that it increased to 0.200 according to what we have there. Now, having said this, when it increased to 0.200, notice that the rate increased to 4.0 times 10 raised to power minus 6. All right, let's get to work. Let's find the order of B. Now, it increased, the factor of increase is going to be given us, let's solve this here. The factor of increase for the concentration of B was 0.2 divided by 0.1, and you notice that it's 2. So the factor of increase here is 2. But when you check the factor of increase in the rate, let's find the factor of increase in the rate. The factor of increase in the rate is going to give us, okay, let me just put that factor like with a different color. So the factor of increase here is 2. Then let's find the factor of increase in the rate. The factor of increase in the rate is now going to be 4.0 times 10 raised to the power minus 6 divided by 1.0 times 10 raised to the power minus 6, which is going to give us 4. So, for us to know the order of reaction, we have to count how many times will these 2 multiply to give me this 4. And that's going to be 2 times 2, which means we are going to have this to be 2 raised to the power 2. Automatically, because the power is 2, the order of this reaction is 2. So have that in mind, that when A is constant, the order of reaction of B is going to be 2. Not because it is multiplied by 2, but because the factor with which the concentration increased was raised to the power of 2. So you are considering the power of the factor to know the order. So this particular reaction, the order is going to be a second order reaction for B. So which means in the rate expression, when we get to writing out the rate expression, the power of the concentration of B is going to be 2. Remember, it is not 2 because the concentration of B increased by 2. No, it is 2 because the factor of increase of the concentration of B was raised to the power of 2. So what we are considering is the power. Let's get to the next one. Now, in the question, in the third trial, we noticed something that in the third trial, A was no more constant. What was constant now was B. So A changed to 0.400. From 0.1 it changed to 0.4. While in the case of B had to change from, B was constant. So B was constant. Now, when B was constant and A changed, the rate changed to 16 times 10 raised to the power minus 6. So let's resolve this. The factor of increase between this and this is obviously 4. This is 0.4 divided by 1. So it's 4. While the factor of increase in this case is 16 divided by 4, and it's still 4. So notice this, that because the factor of increase is the same thing, I mentioned this, that once the factor of increase is the same thing, automatically you have that it is a first order reaction. So which means if we are to express the rate, so for B, this is a second order, while for A, this is a first order. What makes this a first order? Once the factor of increase between the concentration and the rate are the same thing, is a first order. But if you have that the factor of increase is not the same thing, and you now have to reduce them to the same base, and you check the power. If the power of that factor is 2, once the power of the factor is 2, is a second order. If the power of this factor is 3, is a third order. Okay, let's get to work and see what happens now. Now, with this, we will now express the rate formula. How do we express the rate formula? Remember that R is proportional to the concentration of A multiplied by B, basically. And so what do we do about this? R is proportional to the concentration of A. Now we found out that A is a first order reaction, so we are going to put 1 here, multiplied by B, which is a second order reaction, which is 2. So the implication is that if you want to get the order of the total reaction, what did I say you simply do? You add these two powers, and it's going to be 1 plus 2, and what you have is 3. Basically, quite simple, and that is that. This is basically how to find the order of a reaction. Now, what I'm going to do is just to solve one more question, and with that one more question, we will call it off. Now, imagine, for instance, you have different values. Let's try out this new question. Consider the experiment seen in the board where you have initial concentration of A, initial concentration of B, and R as 0.2, 0.2, and 1.0 times 10 to the minus 5. Now notice, in the first trial, A changed but B was constant. So let's find out the order of A. Now, to find the order of A is quite simple. First of all, you check by what factor did A increase. So let's find out the factor it increased by. I told you how to find the factor is simple. This divided by this. So we have 0.6 divided by 0.2. And what you have here is 3. Now, check it with respect to the rate. Let's find out the factor by which the rate increased. That's going to be 9.0 times 10 to the minus 5 divided by 1.0 times 10 to the minus 5. That's going to give us 9. So, what do we do before we know the order of the reaction? If it was 3 and 3, we know it's a first order reaction because the factors of increase between the concentration and the rate are the same thing. So we know it's going to be a first order reaction. But in this case, we have 3 and 9. Question is, how many times will I multiply this 3 for it to give me 9? And that is going to be 9 will be equals 3 times 3. And that is 3 raised to the power 2, which automatically means that this particular reaction for A is a second order reaction. So have that in mind, that the order of reaction of A is second order. Let's find for that of B. In the case of B, we notice that where B was constant between the first and second trial, but between the second and third, it changes. So here we are not considering A again because A is constant. So let's see for B. In the case of B, B went from 0.2 to 0.4. So let's find the factor for B. The factor for B is going to be 0.4 divided by 0.2. And what is that going to give us? This is going to give us 2. So let's check the increase, how it affected this guy now. So 72 divided by 9 should give us 8. So the factor of increase between these two is 8. Remember, I told you how to find the factor is use this final value and divide it by the immediate value lesser than 8. So once you do that, that's 72 divided by 9 and you have 8. And the question is this: how many times will I multiply these 2 for it to give me 8? And that's going to be 2 times 2 times 2. Therefore, I'm going to have that this 8 is equals 2 raised to the power 3. Hence, the order of this reaction is going to be 3. Remember, you are considering the power, not necessarily the factor, but the power of the factor of increase. So with that said, we have that the reaction B is going to be 3. Why is it 3? It's going to be a third order reaction. Having said all this, let's now write a rate law expression for this particular reaction. The rate law expression for this reaction, remember that rate is proportional to the reactants, and in this case is A multiplied by B. How to simply do this is R, you introduce your constant K, concentration of A. Now please, what is the order of the reaction of A? The order of the reaction of A is 2 multiplied by the concentration of B, and the order of the reaction of B is 3. Hence, if you are asked to find the total order of this reaction, the order of reaction is now going to be these powers added together, which is 2 plus 3, and that is going to give us 5. So that's that basically. I hope you've learned a lot and this has been helpful. Remember, this is Witslout, learning made easy. Don't forget to like, share, and subscribe.